Hello everyone, and welcome back to the Fluctus Channel. The United States military relies on several cargo aircraft, but the C-130, C-17, and C-5 form the backbone of its global airlift system. Among them, the C-5M Super Galaxy is the largest aircraft in the Air Force inventory, built to move outsized cargo across intercontinental distances. At nearly 248 feet long, with a wingspan of almost 223 feet and a tail more than 65 feet high, the C-5M dominates any flight line. Its 5 landing gear assemblies carry 28 wheels, while 4 General Electric F-138 engines produce more than 51,000 pounds of thrust each. Those engines replace the older TF-39 power plants during a major modernization program, improving thrust, shortening takeoff distance, accelerating climb, and making the aircraft quieter and more reliable. The cargo compartment is almost 144 feet long, 19 feet wide, and more than 13 feet high. Both the nose and rear doors can open, allowing vehicles and pallets to enter from one end while other cargo leaves through the opposite end. The aircraft can carry up to 36 standard pallets and a maximum allowable payload of roughly 281,000 pounds. With no cargo, it can travel about 7,000 nautical miles. With a wartime planning load of 120,000 pounds, it can fly approximately 4,800 nautical miles without refueling. The Air Force currently owns and operates 52 C-5Ms. 36 serve with active duty units, while 16 belong to the Air Force Reserve. They are based at Dover Air Force Base in Delaware, Travis Air Force Base in California, Joint Base San Antonio-Lackland in Texas, and Westover Air Reserve Base in Massachusetts. The first operational C-5A entered service in 1970, and the modernization of selected C-5A, B, and C models created today's Super Galaxy fleet. Starting an aircraft this large requires a carefully controlled sequence. Before the engines turn, maintainers inspect landing gear, tires, hydraulic lines, control surfaces, cargo doors, and exposed panels. Flight engineers verify electrical power, fuel quantities, oxygen, pressurization, fire detection, and the condition of aircraft systems. The cockpit crew powers avionics, enters navigation data, checks radios, and reviews warning messages. Ground teams remain positioned around the aircraft because the spinning fan diameter and exhaust from each engine create enormous danger zones. The auxiliary power unit supplies electricity and pneumatic pressure for engine start. One engine is started at a time. Compressed air turns the starter, fuel is introduced, and ignition follows. The crew watches exhaust temperature, oil pressure, fuel flow, and engine speed as the turbofan stabilizes. Any abnormal indication can stop the sequence immediately. Once all 4 engines are running, generators are brought online, flight controls are checked, and the aircraft prepares to taxi. Training makes this complex process repeatable. At Dover Air Force Base, avionics students use a C-5M trainer assembled with real aircraft components. Instead of removing an operational aircraft from service, instructors can create faults in displays, navigation units, communication systems, and wiring. Students trace signals, interpret technical data, isolate the defective component, and verify the repair. Engine change instruction follows the same principle. Teams position maintenance stands, remove panels and connections, support the engine with specialized lifting equipment, and disconnect fuel, electrical, pneumatic, and control lines. The massive power plant is then lowered carefully before another engine is aligned and installed. Ground trainers at Dover and Joint Base Elmendorf-Richardson let airmen practice cargo door systems, kneeling procedures, landing gear, and loading operations without risking an active mission aircraft. The aircraft can also lower its cargo deck by kneeling through its landing gear, reducing ramp angles for heavy vehicles. Loadmasters supervise this movement, confirm that the area is clear, and ensure the airplane remains balanced. These procedures are rehearsed on ground training devices where mistakes can be corrected safely. Crews learn to identify hydraulic failures, door malfunctions, warning lights, and communication problems before facing the same conditions during a real departure with valuable cargo aboard under strict time pressure and changing weather conditions worldwide. The result is a machine that appears overwhelming from outside, but is controlled through checklists, specialized training, and coordinated crews. Every successful departure begins with hundreds of small inspections completed correctly before the largest aircraft in the Air Force ever starts rolling. Once the Super Galaxy is ready, the cargo operation becomes a carefully measured exercise in weight, clearance, and balance. Loadmasters study each item before it approaches the aircraft. They record dimensions, axle weights, fuel levels, hazardous materials, and lifting points. Then build a loading plan that keeps the aircraft's center of gravity within safe limits throughout flight. For vehicle missions, the C-5 can kneel at the front or rear to reduce the angle of its loading ramps. Ground crews install bridge plates, inspect the floor, and position spotters along both sides of the cargo bay. A vehicle moves forward only when the lead spotter gives a clear signal. Drivers may have just inches of clearance between mirrors, launchers, tires, and the aircraft structure. During a Marine Corps loading operation, a high-mobility artillery rocket system was guided aboard a C-5. The launcher first approached the ramp slowly, while Marines and airmen checked wheel alignment. Once inside, it was positioned according to the load plan, its suspension was settled, and chains were attached to approved restraint points. Loadmasters tightened each device, rechecked the angles, and confirmed that the vehicle could not shift during takeoff, turbulence, or landing. Helicopters require a different process. Rotor blades may be folded or removed, fluid levels adjusted, and sensitive openings protected. Ground crews measure the aircraft again after preparation because antennae, landing gear, or rotor heads can create unexpected clearance problems. A tug then pulls the helicopter up the ramp while wing walkers monitor every side. Once parked, the helicopter is supported and restrained at several points to distribute loads across the cargo floor. The C-5's enormous interior can even carry major sections of other aircraft. A C-130 fuselage used for training can be lifted onto transport equipment aligned with the loading ramp and slowly drawn inside. Such cargo demonstrates why the Galaxy's opening nose is so valuable. Long objects can pass straight through the front instead of turning through a conventional rear door. Not every mission supports combat. Under the Denton program, Privately donated humanitarian supplies can travel aboard military aircraft when space is available. Pallets containing medical equipment, school materials, food, or disaster relief items are inspected, documented, wrapped, and weighed before loading. Cargo teams arrange the pallets by destination and unloading order, so aid can be transferred efficiently after arrival. The Galaxy has also supported America's space program. Specialized C-5C aircraft were modified with a larger aft opening to carry oversized NASA and spacecraft cargo. Satellites and major components are enclosed in protective containers, monitored for temperature and contamination, and moved with slow, deliberate precision. During transport of space hardware, engineers accompany the load, inspect shock indicators, and verify environmental conditions at scheduled intervals. The C-5 size creates possibilities, but disciplined cargo crews turn those possibilities into safe global missions every time. The C-5 handles the heaviest and most awkward loads, but other airlifters complete missions, demanding different combinations of speed and runway access. The C-17 Globemaster III carries up to 170,900 pounds, yet it can operate from shorter and more austere airfields than the Super Galaxy. That makes it ideal for moving valuable cargo closer to where it is needed. In February 2020, a C-17 delivered NASA's Mars 2020 rover to Kennedy Space Center in Florida. The spacecraft arrived inside a protective shipping container designed to shield it from contamination, vibration, and sudden temperature changes. Ground teams checked clearances and transferred the container slowly. Every movement was coordinated because the rover, later named Perseverance, would travel millions of miles and could not be exposed to unnecessary risk before launch. The C-17 also supports presidential travel by carrying the vehicles and equipment required before the president arrives. Armored limousines, communications vehicles, security trucks, and support equipment are loaded in a planned order. Teams inspect fuel levels, disconnect or secure sensitive systems, and guide each vehicle up the ramp. Heavy chains restrain the wheels and chassis, while loadmasters verify spacing and aircraft balance. After landing, the vehicles can be unloaded quickly and placed into position before the presidential aircraft reaches the destination. Compared with the C-5, the C-17 has a smaller cargo compartment, but its design allows rapid loading, backing, and short field operations. Its reversible engines help the aircraft maneuver on the ground, and its cargo floor can switch between rollers for pallets and a flat surface for vehicles. This flexibility connects major strategic bases with forward airfields that may not accommodate the larger Galaxy. The C-130 Hercules performs the tactical part of the system. It carries smaller loads, but it can use rougher and shorter runways. During joint Marine and Air Force operations, crews have loaded high-mobility artillery rocket systems into C-130 aircraft for rapid movement. The launcher is weighed and prepared, then guided carefully up the rear ramp. Because space is tight, mirrors, antennas, and external equipment may need adjustment. Spotters watch the vehicle's wheels and roof, while the driver follows precise hand signals. After the HIMARS is positioned, chains secure it to the floor, and loadmasters calculate the final center of gravity. At the destination, the restraints are removed, the ramp lowers, and the launcher drives away, ready to join ground forces. This process allows rocket artillery to shift between locations faster than road movement alone. Together, the C-5, C-17, and C-130 form a layered airlift network. The Super Galaxy carries the largest strategic loads across oceans. The Globemaster combines heavy lift with access to shorter runways. The Hercules completes the final tactical movement into demanding locations. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.